The Constitution of India. Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. So we are going to start with our second part of our chemistry textbook, that is organic chemistry. In organic chemistry, we are going to deal with structures, properties, preparations and how these compounds have got and applications in other industries. So today we are going to start with a new chapter, Haloalkanes and Haloarenes. What are haloalkanes and haloarenes? Halo is the name which you have been heard across with halogen group family, that is our 17th group family. Now when an halogen is bonded with an alkane, you call it as a haloalkane. The replacement of hydrogen atom in an aliphatic or aromatic hydrocarbon. When it is aliphatic hydrocarbon, you call it as haloalkanes, and when it is aromatic hydrocarbon, you call it as haloarenes. It results in the formation of alkyl halide and aryl halide. Now haloalkanes contain halogens which are attached to sp3 hybridized carbon. See, we have learnt about hybridization in our +1 class, that is with sp3, sp2 and sp. So when in alkyl halide, when an halogen atom is attached to an sp3 hybridized carbon, you call it as an alkyl halide or haloalkane. But when it is bonded with sp2 hybridized carbon of an aryl group, you call it as an aromatic halide, or you also called as haloarenes. Now in this chapter, we are going to study about the important methods of preparation, physical and chemical properties and some uses of organohalogen compounds. So let us see one by one. Let us learn about the classification of haloalkanes or haloarenes. Now the first classification was on the basis of number of halogen atoms. So when I say number of halogen atoms, it can be 1 halogen atom, it can be 2 halogen atom or it can be 3 halogen atom. See, these may be classified as mono, di or polyhalogen. What do you mean by polyhalogen? More than 2 or 3. You call it as polyhalogen, depending on whether carbon contain 1, 2 or 3 more halogen atom in their structure. If you see the first one, it is C2H5X. Now X represents the halogen here. So since there is only one X here, you call it as a monohaloalkane. Now in this structure, you have 2 X halogens, so you call it as dihaloalkane. And if you see the third one, you have 1, 2, 3. 3 halogen atoms, you call it as trihaloalkane. Now this is aliphatic, right? So you call it as haloalkanes. Now when you take a benzene structure, we have learnt in 11th standard that this closed structure is called as benzene and they are aromatic in nature. So when you take aromatic structure, you call it as arenes, A-R-E-N-E. So I have only one halogen atom, so I call it as monohaloarene. This is dihaloarene and this is trihaloarene. Monohalo compounds are further classified. Monohalo means what? These are monohalo containing only one carbon atom. So monohalo carbon atoms compounds are further classified based on the hybridization, that is to whichever carbon they are bonded, which hybridization that carbon has got is classified into further way. Now what are those? Let us see. First one will be compounds containing sp3 carbon, which means here you can see the carbon which is bonded to the halogen. You can see children, this halogen is bonded to a carbon which should be sp3 hybridized. In such cases what will happen? The halogen atom is bonded to an alkyl group. This group you call it as an alkyl group. So it is bonded to an alkyl group. They form homologous series represented by CnH2n plus 1x. We know what is the general formula for alkanes. CnH2n plus 2, where plus 2, one of the hydrogen is replaced by halogen. So they are further classified as primary, secondary or tertiary depending on the nature of carbon. Now see the example children. This halogen is attached to the carbon where it is primary, that is only one alkyl group is attached to this carbon. The carbon which is holding the halogen atom has got only one alkyl group, so I call it as primary. Now the second structure you can see, the carbon which is holding the halogen atom is having two alkyl groups, so this becomes my secondary. And if you come to the third structure, the halogen atom is attached to the carbon which has got three alkyl groups, which means they are called as tertiary. So depending on the nature of the carbon, whether it is primary, secondary or tertiary, you call it as primary alkyl halide, secondary alkyl halide and tertiary alkyl halide. Now we will go to the next one, which is Alailic Halides. These are the compounds in which halogen atom is bonded to an sp3 hybridized carbon. Same, all these comes under sp3, but what is the difference? It is attached to the carbon atom adjacent to carbon-carbon double bond. Now listen very carefully children. The carbon is holding the halogen. The carbon which is holding the halogen is attached to the carbon which is doubly bonded. Are you able to follow me children? My halogen atom is attached to the carbon which is bonded to a carbon that is holding a double bond. Now if you see here also, this is my carbon, this is holding my halogen. Now this carbon is attached to the another carbon which is having a double bond. So this you call it as a alailic structure. Alailic structure means halogen holding the carbon is not doubly bonded, but the halogen which is holding the carbon which is holding the halogen is bonded to the adjacent carbon which is doubly bonded. So that we call it as Alailic Halides. Next we will see what is Benzylic Halides. Benzylic Halides, these are the compounds in which halogen atom is bonded to an sp3 hybridized carbon attached to the aromatic ring. Here we saw attached to the allylic carbon, that is having a double bond. But here the carbon will be, which is holding the halogen will be attached to the aromatic ring. So what is aromatic ring here? This is my carbon which is holding my halogen. Now that is attached to the allylic ring. This is my aromatic ring. So the carbon which is holding the halogen is attached to the carbon or it is attached to the aromatic ring. The same thing here. This is my carbon. This is holding my halogen. It is attached to the aromatic ring. Such we call it as benzylic halides. Now next we will see compounds containing sp2 hybridized carbon. Previously we were seeing sp3 hybridized, but here it is sp2. Now these are basically of two types. What are those? Vinylic, aryl. What is vinylic? These are the compounds in which halogen atom is bonded to sp2 hybridized carbon atom of a carbon-carbon double bond. The difference between allylic and vinylic you must understand. Allylic, carbon is sp3 hybridized, which is attached to the adjacent carbon atom, that is doubly bonded. But here the carbon that is holding the halogen is doubly bonded. The doubly bonded carbon is holding the halogen. Here also if you see, this is the carbon which is doubly bonded, that is holding my halogen. So that you call it as, see, carbon-carbon double bond will be holding the halogen. So that we call it as vinylic halides. Next one is aryl halides. Very simple. These are the compounds in which halogen atom is directly bonded to sp2 hybridized carbon atom. So this is my aromatic ring which is sp2 hybridized, that will directly hold the halogen atom. So till now we were seeing about the classification of halogen compounds, or I can say aryl halides or alkyl halides. Now when you come to the nomenclature, if you see here children, yes, alkyl halides are named as halo substituted hydrocarbons. This you have studied in your previous classes. 1, 2, 3 we used to do in 10th standard. Remember children, bromopropane or propyl bromide. Here 2-chloropropane, because second carbon is holding the halogen. So why do we write iso here? Because CH is having two similar groups on both the sides. So it becomes isopropyl chloride. Similarly here it is 1-chloro 2-methyl propane, which is nothing but isobutyl chloride. Why it is isobutyl? Because 4 carbon atoms are there. Now this carbon is having same methyl groups, so it is isobutyl chloride. So like that we will be doing the IUPAC names. Now the most important that comes here in this is the dihalo compounds. Very very important children. The dihalo compounds having both halogen atoms. Both the halogen atoms are further classified as two types. One is geminal halides, or we call it as gem dihalides, or we also call it as vicinal dihalides. When the halogen compounds contain both the halogen atoms on the same carbon atom, when the same carbon atom is holding two halogens, you call it as gem dihalides. When the halogen atoms are present on the same carbon atom of the chain and vicinal dihalides. Now what is vicinal dihalides? We will see now with examples. Okay. See here. The same carbon atom is having both the halogens, you call it as ethylidine chloride or gem dihalide. When adjacent carbon atoms are holding the halogens, you call it as vicinal dihalide. What is vicinity? Close by, nearby. So vicinal means the close carbon atoms are holding the halogens. So you call it as vicinal dihalides. When the same carbon atom is holding the halogens, you call it as gem dihalides. Now some of the IUPAC names are given here. You can just go through that children. Now we will get into the preparations of halogen compounds. Let us now learn about the nature of the CX bond. That is, what will be the nature of the carbon halogen bond present in a haloalkane or haloarene. Halogen atoms are more electronegative than carbon, because you know as we go across the period the electronegativity actually increases. So it is more electronegative. So the carbon halogen bond of this alkyl halide is polarized. We have studied about dipole moment, polarization. That is, a pair of electrons is being attracted by the more electronegative atom, which will induce a partial negative and a partial positive charge. So this carbon and halogen atom are having an electronegativity difference, that the electron pair is more influenced by the halogen atom, which develops a partial negative charge here and a partial positive charge. So as we go down the group in the periodic table, we know the size of the halogen atom actually increases. So fluorine being the smallest, iodine being the largest, the CX bond actually it increases. So some of the bond lengths are also given, right? So it is just for us to understand better about, you can see here the bond length, how does it increase? So this is the bond enthalpy. As the bond length increases, the bond dissociation actually decreases because it is easy to dissociate the bond, and this is the dipole moment which also actually decreases. Now let us learn about some of the preparations that we can do for the haloalkanes. When we say preparation, it is the same, children, you cannot change according to your own choice. So you have to learn the reactions by heart. Now the first and the foremost important preparation is from alcohols. The hydroxyl group, because in an alcohol you know the hydroxyl groups are present. Hydroxyl are nothing but OH group. The hydroxyl group of an alcohol is replaced by halogen on reaction with concentrated halogen acids. When I say concentrated halogen acids, it can be hydrochloric acid, it can be sulfuric acid. Also with phosphorus halides, which is PX3, which can be PCl5 also, or with thionyl chloride, that is SOCl2. But of all the reactions, thionyl chloride is preferred because in this reaction alkyl halide is formed along with SO2 and HCl, and two gaseous products are escapable. Hence, the reaction gives only the pure alkyl halides. It is often asked question in the board, why thionyl chloride is preferred for the preparation of alkyl halide. If you see the preparation, children, the first preparation, alcohol plus HCl in presence of zinc chloride, this chlorine comes and attack my OH. So it becomes RCl plus H2O. Now what happens in the second reaction? When it is treated with sulfuric acid and sodium bromide, you get bromine replacing OH, so RBr, and sodium bisulfate and water. The next one is with PX3. Just remember, children, you just have to replace the OH with X. So then you get the balanced RX, the remaining will be H3PO3. Similarly with PCl5, Cl comes and gets replaced, remaining will be POCl3 and HCl. The next one is a red phosphorus reaction. Alcohol with red phosphorus in presence of chlorine or any halogen gives only alkyl halide. The last reaction is a very important reaction with thionyl chloride, where you get RCl plus SO2 and HCl. Now these reactions are very important. You have to learn all the reactions, and you may be asked in fill in the blanks, or you may be asked to write with examples, right? What happens when PX3 reacts with alcohol? How alkyl halide is prepared from PCl5? So you should be knowing the reactions. The preparation of an alkyl halide is carried out either by passing hydrogen chloride gas through a solution of alcohol, or by heating a mixture of alcohol and concentrated aqueous halogen acid. So HCl you can add directly or by treating alcohol with aqueous halogen acids. See, these are not applicable for the preparation of aryl halides. Aromatic halides you cannot prepare using these methods, because the carbon-carbon bond in phenol has got a double bond character, and this is only for single bonded compounds. So now the first preparation is from alcohols, it is over. The next one is from hydrocarbons. So let us see what happens from hydrocarbons. Hydrocarbons are nothing but, it can be alkanes, alkenes or alkynes, but here we are going to see only alkanes. From alkanes, free radical halogen atom. Halogenation, you remember, children, chain reaction we have learnt how each hydrogen will be replaced by the halogen atom, free radical mechanism. Yes, free radical chlorination or bromination of alkanes gives complex of mixture of isomeric mono and polyhaloalkanes, which is difficult to separate as pure compounds. So the single compound yield is always less, because this free radical reaction is a chain reaction. Continuously the reaction goes on till all the hydrogens are replaced by the halogen atoms. If you see this example, butane with chlorine in presence of UV, you get monochlorobutane. Again you get a second position. Again you can get dichloro, again it becomes trichloro and then tetrachloro. So the reaction actually continues, you do not get a single yield in this reaction. The next one is from alkenes. So we saw in hydrocarbons first alkanes, now we will see alkenes. Addition reaction, there it is substitution reaction where hydrogen are replaced by halogens. Here it is addition, the addition of hydrogen halides, the double bond is broken and you get a single bond. What happens here? Alkene is converted to corresponding alkyl halide by reaction with hydrogen chloride or hydrogen bromide or hydrogen iodide. So here I have example ethene, CH2 double bond CH2 plus HCl, the double bond breaks, one hydrogen comes and attacks the one carbon and one X comes and attacks the other carbon. So you get a alkyl halide, right, monochloroethyl, ethane, that is what we get here. Propene yields two products, but however Markovnikov rule predominates. We know what is Markovnikov rule, anti-Markovnikov rule, Karash effect. You remember children, where the halogen will be going to the carbon which has got less substituted hydrogen atoms. So as per the rule, this is propene with HI, you get this as minor product and this as a major product because the hydrogen comes and attacks the carbon which has got fewer hydrogen atoms, which we studied last year in Markovnikov rule. So if you remember that, you can understand this reaction. Next is again a simple reaction. Here we were adding one hydrogen and one halogen, but here we are going to add both halogen atoms to a doubly bonded carbon compound. Addition of bromine in carbon tetrachloride. What is the use of carbon tetrachloride? That is a solvent which is used again to trigger the reaction. It results in discharge of reddish brown color of bromine, constitutes an important method for detection of double bond in a molecule. So when an alkene, if you want to confirm whether there is a double bond in your compound, if you had bromine in carbon tetrachloride, you get a reddish brown color if double bond is present. So what happens? Each bromine atom comes and attacks one carbon, the double bond breaks and it becomes a single bond. So you get CH2, CH2, Br, Br. Now do you remember what is this type of compounds? These are vicinal halides because adjacent carbon atoms are holding my halogens. If both halogens are present in the same carbon, we call it as gem dihalides. So these are called as vicinal dihalides. Okay. Now the next is again an important name reaction. See, when I mark these as important, these are name reactions which definitely comes in exam. The next method is halogen exchange. What do you mean by halogen exchange? The halogen get exchanged with two compounds. Alkyl iodides are prepared by reaction of alkyl chlorides and bromides with NaI in dry acetone. In dry acetone as a medium, we use sodium iodide to react with Rx, where this can be Cl, this can be Br. So one halogen comes here, the other halogen comes to sodium. So you get Ri plus NaX. So when I use sodium iodide in dry acetone, I name that reaction as Finkelstein reaction. Very important name reaction. Now it facilitates according to Le Chatelier principle. What is Le Chatelier principle? Depending on the pressure, temperature and concentration, the system will adjust in such a way that you get both the side balanced reactants and products. Okay. The next one is the synthesis of alkyl fluorides. We were seeing about chlorides and bromides. Iodides we saw Finkelstein reaction. Now next is with fluorine. The synthesis of fluorine is prepared by heating alkyl chloride or bromide in presence of metallic fluoride such as AgF, HgF2, cobalt fluoride or antimonic fluoride, trifluoride, where this reaction we call it as Schwarz reaction. Again another name reaction. If iodine preparation is asked, it is Finkelstein reaction. If fluorine preparation is asked, it is Schwarz reaction where you can see bromo halide, that is alkyl bromide reacting with silver fluoride, you get here fluoroalkane plus silver bromide. This is only one reaction which is used for the preparation of fluoroalkanes or alkyl fluoride. So, do not forget this, children. Okay. The next one we are going to see about preparation of haloarenes. Haloalkanes we were seeing from hydrocarbons, from alkanes, from alkenes. Now we were seeing Schwarz reaction, Finkelstein reaction. We were seeing reaction from alcohols. Now we are going to see how haloarenes are prepared from hydrocarbons. That is, I am going to take a hydrocarbon by electrophilic substitution. When I say hydrocarbon, don't think it should be only aliphatic. Now this is my aromatic hydrocarbon using electrophilic substitution. If you remember, last year we were studying about electrophiles and nucleophiles. Yes children, can you recollect? Electrophiles are those which has got a positive charge in them, that is which are electron deficient species. And when I say nucleophiles, these are electron rich species. So when I say an electrophilic substitution, an electrophile will come and attack a electron rich center. Aryl chlorides and bromides can be prepared by electrophilic substitution of arenes with chlorine and bromine respectively in the presence of Lewis acid catalyst like iron or iron chloride. So this is my arene. I have a benzene ring where CH3 is attached. This is my arene. When it is treated with any halogen in presence of iron or iron chloride in dark conditions, what happens? One of the hydrogen from here gets removed and the halogen comes and gets attached here. So I get ortho para. You remember what is ortho, meta, para, children? This is my substituent. So the substituent, the first carbon we call it as ortho, the second one you call it as meta, and the third one opposite to that, the straight, you call it as para. So from the substituent, the first carbon position is ortho here, second one is meta, and opposite to that we call it as para. 1, 2 ortho, 1, 3 meta, and 1, 4 is para. So you get ortho and para isomers of haloarenes. Now this is very important. Reactions with iodine are reversible in nature, so it requires the presence of an oxidizing agent. Our purpose is to get the product, that is haloarenes, but if it is going to be reversible, what happens? The product I get will immediately give back my reactants. So I use an oxidizing agent like nitric acid or HiO4, right, for the stopping or to prevent the reversibility of the nature, to oxidize the Hi formed during the iodination. And the most important is fluoro compounds cannot be prepared using this method. I don't use this method, electrophilic substitution, for preparing my fluorine reactions. The next another name reaction is Sandmeyer reaction. Again very important. It is a two-step reaction, definite question for the board. So when they are asking what is Sandmeyer reaction or explain Sandmeyer reaction, you should be able to write the reaction. Sandmeyer, I have a primary aromatic amine. What is primary aromatic amine? The functional group which is attached to the carbon is primary, right? Then you call it as a primary aromatic amine. So this aniline, it is called as aromatic amine or aniline. When it is dissolved in mineral acid HX, HCl, HBr in presence of sodium nitrite NaNO2, what happens? I get N2 plus X minus. Now this X can be Cl, Br or anything except for iodine and fluoride. So what happens here? This hydrogen comes out and I get one X joined here. One of this nitrogen also goes there. So it becomes N2 plus and X minus. Now this benzene diazonium chloride, when it is treated with cuprous chloride or cuprous bromide, it gives my aryl halide. You have to by heart the reaction, children. So this N2X comes out, only X will be replaced there, nitrogen will be escaping as gas. So primary aromatic amine, when it is treated with sodium nitrite in presence of HX, you get N2 plus X minus. This removal of nitrogen takes place in the second step with the formation of aryl halide in the presence of cuprous chloride or cuprous bromide. Now, if I want to prepare my iodine, I cannot use cuprous chloride or bromide. What should I use? A presence of cuprous halide, and it is done by shaking it with potassium iodide. Here in place of Cu2X2, I should use here Ki. When I use the same reaction instead of Cu2X2, if Ki is given, my compound will be my iodoalkane, or I can say alkyl iodide, and with nitrogen as my byproduct. So I hope you are able to follow this, children, the preparation of haloalkanes and haloarenes. Children, I hope you understood today's topic. So we will be getting back into the next topic in the next class. So continuously read the text as of this is organic chemistry. Mark the important things which I have highlighted so that you don't miss those important points. Take care, children. Bye.